Well, let's just start with one previously shown. One like this anyway. Yeah, if I'm wanting to find the zeros of that, of course by that I mean, by zeros I mean it's where f of x equals 0, right? Is the zeros. And so the way we previously did it was set f of x to 0, because then we could solve this equation, you know, factoring, whatever. We had some techniques we used. See this, I do believe factors, yeah, minus 6 and positive 1, using minus 5 in the middle, set the two separate factors to 0, okay, and we got it. Okay, well, that's all well and good, but what if I have f of x equals x to the third plus 2x squared minus 5x minus 6? Well, the thing about that is, if I set that f of x, talking about the zeros again, thing about that is, if I set that to 0, with what we previously have done, that's going to be a hard thing to factor. Now, some of you might be thinking, well, factor by grouping, something like that, but even factor by grouping, if you know anything about that, is not going to work on factoring this particular polynomial function, degree 3. Yeah, I just can't factor it as previously done. Okay? However, we're going to talk about another way of doing this, and that is using synthetic division. If I think about, well, one thing I do need to mention, I haven't previously mentioned, is that, yeah, I'm going to use synthetic division here, and I'm going to use it to synthetically divide x minus 2 which, here's what I get. Let's just use synthetic division here to divide by x minus 2. Okay, and so the reason we talked about synthetic division is because it makes it easy, an easy deal here to do that. If I synthetically divide here by x minus 2, here's what I get. Well, if I'm synthetically dividing by x minus 2, that really is going to put in a 2 there, right? I'm going to put a 2, do the opposite sign. Is the way that works. And then alongside here, what do I put? Well, I put the coefficients of the f function. That's what I'm dividing. So I'm going to put alongside it 1, 2, minus 5, and minus 6. And we'll talk about a few things that happen here. So if I do that, what do I get? I get 1. 1 times 2 is 2. 2 plus 4 is 4. 4 times 2 is 8. Negative 5 plus 8 is 3. 3 times 2 is 6. Negative 6 plus 6 is 0. Okay, so first thing first. When I get a remainder of 0, I haven't mentioned this before. When I get a remainder of 0, what that means is, one thing this means, it means the number in the box up here is a 0 of the function. Remainder 0 means the number up here in the box, 2, is a 0. It's a 0 of that function. Okay, that's nice. Get a 0 here, you got a 0 here. Okay, so 2 is a 0. So we've got one of our zeros found. Now, what if that isn't a 0? Well, if that's not a 0, then that's not a 0, okay? But if you get a 0 here, then that's a 0 there. If it's not a 0, it's not a 0, okay? So that's pretty nice. So we've got a 0 of our function with the 2. Now, even more than that, too, there's a link. Here's the zeros over here of this function, and here are the factors that come from those zeros, or what those zeros came from. So doesn't that also mean when I get a 0 of the function, don't I have a factor also of the function? What does that mean about this right here? Isn't that a factor? It also means x minus 2 is a factor of the function. And here's something else. All right? 2 is a 0, so x minus 2, we did that before. We made that linkage before. But here's something else extra. There's also another factor involved, and it comes from this quotient. What is the quotient? Well, the quotient is x squared, 1x squared, right? Because I started with x cubed, so it would be 1x squared plus 4x plus 3. That's going to be my quotient. Well, it turns out x minus 2 is a factor, and there's some other factors that go with it. And preliminarily, I guess you might say, we can also say this is a factor. So when you get that 0, a lot of good things happen. You get another fact, you got a 0 of the function, you got a factor of the function, then you got another factor. So also the quotient is a factor. X squared, in this case, plus 4x plus 3 is a factor in this case. Okay? All that happens because I got that 0 right there. I got a 0 of the function, I got a factor of that function, and then I've also got the other factor. Here's the rest of the story, as they say. Okay? The goal was to find the zeros. I found one of them. How many zeros are there, though? Well, if it's x cubed, there's 3 zeros if you count multiplicities and all that. I found one of them. I still need to find 3 of them, though. 2 more. Well, here's the thing. I found one of the zeros, there's 2. But what I also found was this is a factor, so x minus 2 is a factor, and then I also found that x squared plus 4x plus 3 is a factor. Now, why does that help me find the rest of the factors? Well, because now that factor, of course, gives me that 0, 2, but can I find the rest of the factors right here and the rest of the zeros right here? How could I do that? Just keep on factoring, right? If I keep on factoring this, then I wind up with x minus 2, and then this is now something I can factor. How does that factor? Well, it's x and x. 3 with 4 in the middle, that's 3 and 1, isn't it? So what are my other zeros? Well, the other zeros are going to be 0, 2. Then that's going to be 0 of negative 3. That's going to be 0 of negative 1. Okay? How about that? Question? Huh? The number 0, do I have to write 0? No, not in this case. 0 itself is not a 0. When is 0 a 0? 0 is a 0 if you have a factor, a common factor of x. Right? And we don't have that here. Because that one doesn't have an x. X is not a common factor, so therefore 0 is not a 0. So yeah, good question. All right. So that's kind of the deal. What we're going to do using the synthetic division is we're going to try to find a zero, meaning a zero remainder, when we do our synthetic division. Okay? Now, I gave you kind of where to start on this one. But when we get to these others, we're going to have to kind of know a little more about where to start. And let's also make another little note here on these. Do you notice that all of these zeros, they are integers, not fractions or anything like that. But notice something about them, and then this last, the constant term of the previous, or of the polynomial there. Notice that these 2 and -3 and -1 are all factors of -6. 2, -3, and -1 are all factors of the constant term, the -6. And that's not by coincidence. That will always happen. If it's a zero of the function, and it's an integer, and there's a couple others, turns out it will be a factor of the constant term. Now, why do I point that out? Well, let's just take a look at this. Let's say I've got another one, trying to find the zeros up. F of x equals 2x squared, 2x cubed, plus x squared, minus 12x plus 9. I want to find my zeros, which, being a third degree, there's 3 zeros. All right, and so once again, looking at that and trying to factor it just right out of the box, not going to happen. Okay, you just can't look at that and say, well, this factors into these 3 factors. It just doesn't work quite that nicely. However, using some of the things we learned on the last one there, what we know is that if I find a zero that's an integer, it's going to be a factor of this. So here's what we can do with that. Let's make a possible zero list. Because it turns out the possible zero list, on that list, we need factors of 9 as one potential, some potential of zeros. Okay? So what are we talking about there? Could be 1, 3, 9. Okay, but looking at the ones from the previous, what else could we throw in the mix? Can we also have the negatives of those? Because actually, what was it, -3 and -1 of the 6 of the last one? So it could be plus or minus 1, or plus or minus 3, or plus or minus 9. So you got 6 potential ones right there. Not saying that all of them are, obviously, because there's only 3 of them. But that's 6 possibilities. Now, let me also go ahead and mention, just kind of FYI, what else can happen is this part could come in to play as well. And it does here, matter of fact, so let me go ahead and mention. Turns out that not only factors of this, but if you do factors of this divided by factors of this, which really we're dividing here by 1, the factor of 2 of 1. Divide all these by 1 is what we're saying there. But what else could we divide by? If you do factors of this divided by this, those are also potential zero factors. We don't usually have to get into those, but possibly you could. Here's what I mean. If I take the factors of this divided by 2, basically. So that's factors of the constant. We call it, sometimes they list it as P over Q or something like that. Those are also potential factors, which, like I said, you don't usually have to get into the fractions, but that's how you can get the fractional potential factors. So this is factors of 9 divided by factors of 2. Which I guess really this is 2, but usually, I guess my point is, usually you can get by with just doing the factors of this. But to make the full list that they may want you to make, you also have to divide by the factors of 2, which is the last number on top, and then factors of the first number on the bottom. Okay. So we'll see that has all of the factors that we'll get. Okay. Now what do we do with that? Well, we're looking for zeros. And by zeros, so this is where synthetic comes in. Now I'm going to take some of these. We're going to have to do all of them, but start with those. Some of these. And we're going to use synthetic division to find my zeros. And really, if you think about it, all we need is 1, because that's all we found last time, and that got us all 3 after a little bit more work. Okay, so let's just start. Let's start with 1. The first one on the list there. Start with 1. All right, so 2, 1, negative 12, and 9. I just started with the first one on the list, positive 1, and see what that gets me, and use my synthetic division. And these, where did I get these? 2, 1, negative 12, and 9. Where did those come from? Those are my coefficients of my polynomial there, and the constant. All right, well, I think we're in business here, because if we do that, bring down the 2, and then 2 times 1 is 2, 1 plus 2 is 3, 3 times 1 is 3, and negative 12 plus 3 is negative 9, and negative 9 times 1 is negative 9. And so we're in pretty good shape there, aren't we? Because is 1 a 0? Yes, it is. Since I got a 0 remainder here, 1 is a 0 of the function. Okay? So there's 1 0. How do I get the others? Well, what I can see from the others, this, what is that now also? It's a factor. So 2 would be 2x squared plus 3x minus 9. I've got a 0 here, but I've also got factors. And matter of fact, this is a factor. And so if I set that equal to 0 and factor it some more, that gives me the other zeros. So I can factor this now. 7 to 0, so that would be 2x and x. With minus 9, I think we can go with 3 and 3. Yeah, 3 and 3. Positive 3 here and a minus 3 there, because that and that gives me a 6x, and that gives me minus 3x, so that does give me the middle term of 3x, doesn't it? With me? So 2x minus 3 set to 0, and x plus 3 set to 0 gives me my other. This would give me add 3, give me 2x equals 3, then divide by 2, so we got x is 3 halves. Here subtract 3, so we got negative 3. So what are my zeros? Well, the one I found first was 1. Then I found the other two to be 3 halves and negative 3. Okay? All right. Now, notice those are on my list. Positive 1's on the list right there. Negative 3's on the list right there. And even 3 halves is on my list if I do it out all the way there. Because 3 halves is... So yeah, this list, if you do a list like this, it'll always have all the zeros, and it just, the list here, that just gives you some to try. What am I going to try finding zeros since I can't factor it right up front? This gives you the possibilities, and they will be, if you list them all out, they'll all be on there. Okay? All right, now if I also ask, which I probably will, What's factored form of the original polynomial 2x cubed plus x squared minus 12x plus 9? Could you do that? Well, yeah. Here's, this was a factor, so this was a factor. So there's two of the factors. You need three factors. What about it? Well, the only other one that's there is, this is a 0. And so there is a factor involved there, isn't there? We didn't write it out, but what factor would give me that 0? Wouldn't it be x minus 1? So here's my three factors: x minus 1, 2x minus 3, and x plus 3. With me on that? So factored form, if you want that, you can get that too. All right? Okay. So let's try another one. This one's good. Excuse me. This one's going to be 4th degree. 4th degree. Polynomial function. So it's got lots of factors. All right, f of x equals 2x to the 4th plus x cubed minus 28x squared plus 9x plus 36. So let's find the zeros and factored form all together here. Well, we know how many zeros are there. 4 zeros. This is 4th degree. So I've got to look for 4 here. And so that's going to add a little something to this as well. All right. Well, okay. Where do we start? Good question, right? Well, what are my possible zeros? Well, as we said, some of the possible zeros are just factors of that. 36 has a lot of factors, doesn't it? 1, 2 is possible, 3, 4, 9, 8, 6, 12, and 18, and 36 even. And then, if we want to get into fractions, we could divide all those by 2. Oh, I forgot one, didn't I? 6? There's 6 in there. What else? Or minus those, right? Plus or minus any of those? So there's a lot of, surely one of those will work, at least. But like I was saying, 2, then I could also get into, well, I could do plus or minus a half. Now, 2 divided by 2 would give me 1 again, and then I could do 3 divided by 2, and then I could do 4 divided by 2, which that would just give me 2 again. 6 divided by 2 will give me 3. 9 divided by 2. See what I'm getting those? Just divide those by 2. Actually, I think that's it. Okay. So anyway, lots of potential ones. Let's start with 1. So if I start with 1 here, I've got 2, 1, minus 28, 9, and 36. All right, so that's 2. 2 times 1 is 2. 1 plus 2 is 3. 3 times 1 is 3. Negative 25. Uh-oh. 1 is 0? No. Because I didn't wind up with a 0 remainder. So they won't always work out nicely with your first choice. So we go to 2. Try 2. 2, 1, negative 28, 9, and 36. 2, 4, 5, 10, minus 18, minus 30. Doing these quickly, so. Yeah. Oh, good. It's minus 18. So your second choice may not work. Let's go to 3. 2, 1, minus 28, 9, and 36. 2, 6, 7, 21, negative 7, negative 21, negative 12, negative 36. Aha! Found a 0. Fine. So you may take a little searching. But that's why we're using synthetic division here, because you can do those quickly. Finding zeros quickly. All right, so that helps us out a little bit. We found one of the zeros, but there's 3 more to go. Well, here's a factor, 2x cubed, right? Because this is 1 degree less than what I started with. So it's 2x cubed plus 7x squared minus 7x minus 12. Now is a factor. Okay, but this gives us another little bit of trouble here because, can I factor that now? Not so much easily, can I? I can't factor this like I did a while ago. When I got to this point, I can say, well, I can factor that now and get the rest of the zeros. But I still can't factor that using our typical 2 parentheses or whatever factoring. So what I'm going to do now. Let's use synthetic division on this to find another one. Okay, well, same thing. I can do the list again, but if they're going to be part of this list up here. And matter of fact, using some information before, should I try 1 on that? Probably not. 2, because if it's not a factor of this, then it's not, or 0 of that, then it's not going to be a 0 of that either. So 1 and 2 are off the list. Let's go with the negative. Let's try negative 1. Just on a wild hair here, because we know there's probably some negatives, and well, I guess I could try 4 and 6, but let's try negatives. All right, negative 1. And, when I'm using synthetic division on this, I'm going with those numbers now. Instead of these, I'm dropping it down. Because the idea is I want to drop this down to x squared, and so if I go back to the x to the 4th, I'm not going to get it to x squared. So, yeah, once you find 1 0, then go with its quotient and do your synthetic division on it after that. Okay, so that's 2. 2 times negative 1 is negative 2. 5 minus 7 is 5. 5 times negative 1 is negative 5. Negative 7 minus 5 is negative 12. And negative 12 times negative 1 is positive 12. Negative 12 plus positive, hey, good deal. So now we've got, here's another 0. Roll it at 3. We've got 0 now of negative 1. Well, if I wanted to, this is now what? 2x squared plus 5x minus 12, because now this 2 goes with 1 less power. So I'm down to 2x squared. Okay. I could keep going with synthetic division, but I could also, now, since this is an x squared, now I can do my factoring. But you can keep synthetic division going there if you wanted to. I'm going to go ahead and factor it, though. That's 2x and x, minus 12 with 6 and 2. No. 3 and 4. Yeah, let's go with 3 and 4 there. 3 there, 4 there, and a positive and a negative, because I think that's positive 8x, and that's minus 3x, so that gives me positive 5x, like is in the middle. With me? All right, so 2x minus 3, set up to 0, x plus 4. Yeah, there's my other zeros, isn't it? Add 3, divide by 2. Subtract 4, negative 4. So, all told, these, what are my zeros? Well, I found 3 was 1. negative 1, 3 halves, and negative 4. Those all on the list. 3 is, negative 1 is, 3 halves is, negative 4 is. Yeah, so that was a good list there. What's my factored form of this polynomial here? Well, here's 2 of them. The other two come from this. So the f of x equals x minus 3, x plus 1, and then the other 2 came from that. 2x minus 3 and x